As promised, here is your lesson on radicals. Most of the time, a lot of the times, it'll be a very simple exercise. Square root of 36 is 6, square root of 49 is 7. Square root of 48, I look for the largest perfect square that divides evenly into 48. And that would be 16. And 48 is 16 times 3. And I can break that down into the square root of 16 times the square root of 3. And I can then take the square root of 16 and get 4. And so I'm left with 4 times the square root of 3. In a very similar fashion, the square root of 75 is equal to the square root of 25 times 3. 25 is the largest perfect square that divides evenly into 75. I can then break it down. The square root of 25 is 5, and I'm left with 5 times the square root of 3. Now looking up in the right-hand corner, the square root of x squared is x. The square root of x cubed would be the square root of x squared times the square root of x. Just broken it down. And we already know the square root of x squared is x, and so I'm left with x times the square root of x. X to the fourth is x squared. Drop down quickly, x to the sixth is x cubed. So what's happening every time we have an even one? There's no square root sign left. X to the eighth would be, the square root of x to the eighth would be x to the fourth. Now x to the fifth. Well, x to the fifth is x to the fourth times x. And x to the fourth square root of that is x squared, and I'm left with x squared times the square root of x. X to the seventh, the square root of that is the square root of x to the sixth times x, and the square root of x to the sixth is x cubed. So I'm left with x cubed times the square root of x. Now back over to the left-hand side. The square root of negative 25. Plug that in your calculator and it'll give you an error. Here's how we're going to deal with that. Well, the square root of 25, the square root of negative 25 is the square root of 25 times the square root of negative 1. The square root of 25 is 5. From here on in, the square root of negative 1 will equal I. That's an imaginary number. Calculator can't do it, but we're going to call it an imaginary number, I. So the square root of negative 1 is I, which means that I squared would be equal to the square root of negative 1 times the square root of negative 1, which is negative 1. I cubed would be this negative 1, which I got from I squared, times another I, which would be the square root of negative 1. So that's negative 1 times I, or negative I. And I to the fourth is the same really as I squared times I squared, which is negative 1 times negative 1, which is equal to 1. Let's keep going with this theory. I is the square root of negative 1, I squared is negative 1, I cubed is negative I to the fourth is 1. I to the fifth would start the process back over. I to the fifth would be I to the sixth would be negative 1, I to the seventh would be negative I to the eighth would be 1. And it circles again. I to the ninth would be I to the 10th would be negative 1, etc. And I to the 12th will be 1. And if I keep going in that pattern, every 4 times I'm going to get 1. So I to the 12th is 1, I to the 16th is 1, all the way up to and past I to the 64th is equal to 1. So if I'm doing I to the 65th, then that will be I to the 64th times I, which is 1 times I, or I. Now let's practice a little more with that imaginary